IPS firewall and honeypot, and we'll also go through some demo versions of some of the firewall. So just to get the look and feel of all the firewalls that are there in the market right now. So we'll understand those. So if you are, going out for interviews in the field of cybersecurity, so firewall, IPS, IDS are some of the major tools that are present and widely used everywhere. I mean, there might be some tools which are not present in any of the industries, but IPS, IDS, and firewall are always there, especially firewall. So first we'll look at the IDS. So IDS is basically something that works on signatures. So there are inbuilt signature database that is present uh, in the IDS, and whenever a traffic comes, the traffic is compared against that database, and if there is whenever the signature gets matched with the traffic that is coming through, then it is indicated to the admin person who looks at with around with the traffic part, or who is this security person who looks at the maybe firewall or anything. They'll immediately get notified. Okay. Now, what does this mean is the signatures are basically based on the traffic patterns, or it may be some, packets that are present in over the network that are present. And whenever it sees that signature is getting matched or something, that particular pattern or any particular indication is there. For those, that signature database is created. The screen is visible, right? Hello?
Yes, sir. Yes,
Mm.
sir.
Okay. So basically, it can be a software system or a hardware device, and it inspects all the inbound and outbound traffic. And if any suspicious pattern is, observed or something like that, then it will, compare it against its database files, and based on that, it generates an alarms. So yeah, so basically these are placed, outside or inside the firewall to monitor suspicious traffic, either originating from inside the network or outside the network. So inbound or outbound, both these traffic are monitored. So as you can see in the flow chart as well, uh, any traffic that is coming from the internet, so it arrives at router, the packets are sent to the firewall, and then after firewall allows it, it are passed on to the IDS, and then the IDS flow chart works over here. So it compares it with the signature file database. If it is matched directly, it is communicated to the enterprise network. Otherwise, if any anomaly detection is present and it is matched, and then it either cuts down the traffic itself or notifies the admin. That packet can be dropped from here, and then the admin carries out next part of the work. So now, what is anomaly detection? So anomaly detection, as I told you in the previous lectures as well, if there is some abnormality that is observed, correct? So let's say, I mean, we'll see in the coming examples, but if some there is some sudden increase or spike in the network, or traffic is coming from an unknown source, or there is some changes in the traffic pattern that is not regular, that happens in the network. So such kind of things are observed, and immediately based on that, the anomaly gets detected. So something that happens irregular, that is known as anomaly detection. Okay, let's see how it works. So what are the detections present on the IDS? So First is, as I told you, signature recognition. So if any signature, that are the database that is present in the signature, if let's say, it identify like, as I told you, like, the signature file database for the IDS is, something where uh, a predefined patterns are there, similar to what, I explained in the antivirus also, right? So antivirus also has some signatures that is present. The signatures is whether that particular for antivirus, I'm saying. So in antivirus, what happens is if there is any particular code or something is there, right, where some like so let's say for keylogger, the functionality is present. So such functionalities are present in the signature database. Similarly, those kind of signatures are present for the network part, and those are present in the IDS. So first is the signature recognition. Second is anomaly detection that I already told you, right? It detects intrusion based on the fixed behavioral characteristics of the user and components in the network system. So anything that happens, that is not regular activity in the happening in the network. Uh, in that case, the anomaly detection occurs. And protocol and third one is the protocol anomaly detection. So in this type, models are built to explore anomalies in a way in which vendors deploy the TCP/IP specification. So anywhere, where your regular traffic, let's say in TCP/IP three-way handshake, that we saw multiple ways to check the what we can say, have perform the uh, scanning and everything, right? So particular flags are set, and there are some ways through TCP, what we can say, TCP flood, or even the scan was there, right? Half open scan, TCP connect scan. So in such cases, there will be some protocol anomaly where it will be some flags are sent and some random communication will start happening. So those are also detected by IDS. So general indications of intrusions are coming regarding the file system intrusions, presence of new or unfamiliar files in the system, or changes in the file permissions of file which has usually, high privileges, changes it to low privileges, then unexpected changes in the file size. So we saw in the steganography as well, right, where whenever we hide some message in that image, the size of the file increased. So such are also the instances. Rogue files on the system that do not correspond to master list of the signed file. Any random file, or files that indicate some malicious activity, those files that are present which do not align to any of the parent files or something like that. Then there are also some missing files are there, if related to system, as well as some confidential files. So all these are indications of intrusion. And coming to network intrusions, repeated probes of the available services on your machine. So if some random traffic that is coming out, or some scanning or something like that is coming onto your network, that is also an indication. Connections from unusual location. So if, let's say, if your organization does not have business in Cambodia or Colombia or anything, and you see login connections or any traffic that is coming from that location, then also that is an indication. So repeated login attempts from remote host. So if you see, there are some VPN users. So uh, there are some alerts also right present, where if you see, multiple logins from a remote host from multiple IPs. So such indications are also there, which indicate an intrusion. And a sudden influx of log data. I mean, there is some increase or decrease in the log file data that we'll explain, in the later sessions. So, whatever activity you do, there are some log files present. So, if there is some sudden change, then that is also an indication of the intrusion. System intrusions are like again the same thing. Short or incomplete logs, some logs are erased or something like that is there. Then your system getting slow, logs are missing, or the changes of in the ownership or the files permission is occurs, modifications to system software and configuration files. So there are critical files, or so let's say there is some registry files, or it's the what are the critical files are there. If some modifications are those are done on those, then those are also some indications. Unusual graphic displays or text messages, indication of any, if any, if you happen to have infected with the virus as well, you see such kind of symptoms. Gaps in accounting, system accounting, if your system crashes or reboots, or unfamiliar processes. So if you run your task manager and if you see the processes that you are seeing are not related to any of the applications that you have installed. So yeah, these are the indications. This is one of the question that, especially on the pressure level, is asked. What are the types of indication and what is difference between them? So one is your network-based intrusion detection system, and another is your host-based intrusion detection system. So network-based is basically something that works on the network level, and host-based is what works on your system level. That is the main the prime difference between them, and the working remains almost the same. So if you see the system, the network one basically consists of a black box that is placed on the network in promiscuous mode, listening for pattern indicative of intrusion. So all the traffic, the promiscuous mode is that we already seen, uh, which means is all the traffic will be sent to and from the IDS, and it will just look all at the patterns that are going to and from. It detects malicious activity such as denial of service, attacks, port scan, and everything. And host-based, you can see that this system usually include auditing of event that happens on a specific host. So as I said, those are system specific. So usually, if there is a host-based IDS placed, then uh, it will be installed, that agent will be installed on your system, and all the activities that we saw, same thing will be done on your uh, I mean the detection part will be done on your host level. So over whatever we saw over here, right, these system intrusions that will be monitored on the IDS, and network intrusions are done on the this thing network based IDS. So, but however, usually this question is also asked, then, what would you recommend? Should it be a host-based intrusion detection system or a network-based detection system? So usually your answer should be like, it depends on the size of the organization. So if your organization is small and you want to have a secure network, at that time you can have host-based one, because like it is also mentioned over here that due to the overhead, they incur to have by having to monitor each system event. So this is not something that is usually done. And if your organization is, a bigger one or something like that, then the network-based intrusion detection systems are placed so that your whole network gets monitored. And on the large network organizations, it is very difficult to have IDS on all the systems. So yeah, so any organization where which is a large in number, they usually avoid the host-based intrusion detection system. Again, these types of alerts, even though like we are discussing them in what we can say in IDS alerts, however, these concepts are there that are present always in your cybersecurity field. So any uh, cybersecurity field that you are working on, you will come across these concepts on regular basis. which is true positive, false negative, true negative. So now, what is true positive? So, true positive is something when IDS raises an alarm when a legitimate attack occurs. So let's say if an IDS has raised an alarm, and it turns out that the alarm that has it has raised for it is actually true, and it is actually an attack that is happening. So that is called as true positive. False positive, also known as FP. So in this case, what happens is IDS raises an alarm and there is no attack that takes place. Actually, so what happens is basically, let's say, I told you, right? Uh, IDS has some signature files that are present or signature database that is present, and your alarms will get triggered based on that. So it is not necessary that all the alarms will be, an actual attack. Most of them are actually, if you see, are false positive. So they are, let's say, if also sometimes a legitimate traffic will also have some indications which may indicate. So let's say, for an example, I'll take an example over here of antivirus. Now, antivirus has some signature, right? So what happens is it will, let's say, see any particular code for an application is present, and that same code or same type of indication is also there in a legit file, legit application as well. So as per antivirus, it will be a an alert, so it will raise an alarm for that, but actually it is a legitimate file. Similarly, what happens in IDS as well, if any attack occurs, or alarm gets detected based on its signature, however actually there is no attack that is taking place. So this is what same thing applies in IDS as well. Then there is false negative. So sometimes what happens is an attack gets happened and IDS does not generate an alarm for that. Those are called as false negative. Reason is maybe those database signatures are not present over there. It may be a zero-day attack, or that signature database is not updated. Anything can be the reason. But thing is, like, the actual attack happened and IDS did not raise an alarm for that. That is known as your false negative. And the last is true negative. That IDS does not raise an alarm when an attack has not taken place. So this is something which is not a very famous, or that we come across this, that alarm also is not triggered and attack also has not taken. The event may take place. So thing is, an event may occur which should generate an alert, but it did not generate an alarm for that, but the attack also not was there. So let's say if some file, again, like, we'll go as an example, we'll also take an antivirus example along with this. So if a file uh, functions in a way in which the actual antivirus also, sorry, and actual virus also has this same type of pattern behavior. So in that case, however, that is a legit file, but it has some, functionalities or some features like of an virus. So for that, we expect that alert to be get triggered, but I mean, the alert also does not happen, and the attack is also not an actual attack. Another example will be, let's say, if you, let's say, if your log file get, now what we saw an example, right? An indication of your intrusion. So let's say if you make some altercations on your log file, now ideally that should generate an alarm. However, it was a legit activity, but legit in the sense, like, I have done some activity where I have to clear logs. Okay. So usually that happens to clear up the space, and you have cleared your logs. So this is kind of thing where your alarm should get triggered. But IDS does not raise an alarm for that, even though it is not an actual attack, but still it should have generated an alert. So these are the four type of alert which you'll see in any of the department that you work on. Either you work as a SOC analyst, either you work as malware analyst, either will work as, VAPT person or VAPT team, anywhere. These four concepts will always be there. Then next is IPS, that is intrusion prevention system. It is same as your IDS, just it has an enhanced feature of preventing as well. So let's say if it sees any signature or any pattern similar to what we saw in IDS, so it will not only generate an alert, but it will also block that traffic. So obviously there is also passive and active IPS IDS. So if it is passive, then it will block it. If it is uh, sorry, if it is uh, what we can say, active passive, we'll see that in coming lectures. But just to avoid the confusion, if it is passive, then it will actively analyze and automatically take decisions on traffic that is entering the network. Usually, IPS is now what is used in regular organizations. IDS is somewhat getting replaced by IDS. However, there are some organizations who are on the defensive part, who will say that since they don't want their traffic, legit traffic, to get blocked, they will use IDS. But usually it is recommended to have IPS. So let's say I gave example of some of the uh, legit ones as well, right? So there is some pattern which is actually a malicious pattern which IDS detects it or IPS detects it, but actually it is a legitimate traffic. But since it has signature triggered, IDS will generate an alert only and inform the admin. IPS on the other part will directly block the network, though it is a false positive. False positive in the sense that what I told you, right? So the alarm will get triggered, but it is a legitimate traffic. So this can hamper business in lot of ways. Same thing. Advantages of IPS are, unlike IDS, IPS will block all the illegal packets coming into organization. It is used to monitor activities in a single organization and can prevent occurrence of direct attacks in the network by controlling the amount of network traffic. Then coming to firewall, so there are two types of firewall, hardware and software. So basically, they are the first lines of defense in any organization. So whenever your internet traffic terminates in your organization, usually it terminates at the internet switch or internet router, and then through it is passed on to the firewall. And firewall is responsible mostly to decide what traffic should be allowed in your organization and outside organization. So all the traffic that is going to and from is mostly controlled by your firewall. I mean, it is, as I said, first line of defense in an organization, and it is very important to have a firewall. Also, firewall is also responsible to route the traffic and everything. But as concern of the security part, it's most of the important part is where it should block the traffic. They are placed at the junction or gateway between two networks, which is usually private network and public network, such as internet. That's what I said right now. And it examines all the messages entering or leaving the internet between, I mean, the same thing, between your local network and your internet. It will examine all this and block when a specified security criteria is met. Now, uh, how it actually works is basically there are some policies that are present on the firewall. Now, those policies are the one, as I said, that decide which traffic should be allowed and which traffic should not be allowed. Now, let's say if you decide that obviously, there are some protocols or some ports that should not be allowed your organization to have it directly with the outside world. Consider you are allowing HTTP traffic in current scenario. Now no one uses HTTP traffic. Why? Because it is insecure. Everyone uses HTTPS. But for some reason you decide that you have to allow HTTP traffic, which is on port 80. Now this will basically uh, be a threat to your organization that you have allowed HTTP traffic to be going to and from. Hence, a firewall policy can be created which will block any traffic that is going to and from the HTTP port. So such policies are basically created at the firewall end. So so there are some rules, right? I'll show you. We'll go, as we see. Now we'll also have the some demo version of firewall, which which you'll see and you'll understand how the actual traffic or how the rules and policies are set. So basically, those are where you have to enter the source or destination and also the protocol, and then you have to decide if you want to allow the traffic or block the traffic. Now, let's say if you want to block all the HTTP traffic coming to and from the network, in that case, what you will do is you can't mention all the IPs, right? So what it does is it has any rule. Now, what does it mean is basically uh, any any IP from the private network or any IP from the public network. If it matches the certain criteria, it doesn't matter what is the IP and everything, what subnet it belongs to. Any traffic that is coming through HTTP should be blocked. So port number is given, protocol is given, and action is given as block. So this is how the basically firewall is configured. So coming to firewall architecture, there are three types of architecture that are there based on it, like how you want to basically implement your firewall. So Bastion host is the regular one, which is designed and configured in the same way where it will act as an wall between your uh, internet and the intranet. This DMZ and everything we'll see in detail. So I'll explain you what exactly it means. So DMZ is basically where you want to create a different, what we can say, a different network, a isolated network from what is there between from your internet. So let's say there are 5 or 10 critical web servers that you want to, protect it from the uh, outside world. So what you will do is for that, basically through firewall, as I said, firewall also works as an router, not router as such, but it can also route the traffic. So what it does is over here you can see from the internet, here is your firewall. Now what firewall will do? Firewall is connected to your intranet as well. That is your private network of an organization, and along with that it is also connected to a DMZ. These DMZs are a group of servers or web servers, whatever it is. It may be servers, web server, anything. Those will be uh, having a different, what we can say, a different network itself, which will secure itself from the uh, companies or organizations network. So basically, it is created by a firewall with 3 or more network interfaces. Obviously, it will have some network interfaces assigned with specific roles such as internal trusted network, the DMZ network, and external untrusted network. So there are some interfaces that are present at the firewall. One interface will be connected to your public network, one interface will be connected to intranet, and one connected to the DMZ. And you can apply, like let's say if you want some particular port that needs to be allowed in this corporate network, but you don't want to be allowed into this particular network because these are your all critical servers. So in that case, you will make sure that a policy is created where that particular port traffic will go and to from the internet and this intranet. However, for DMZ, that is not applied, it will get blocked. So basically, it is kind of a special, why it is called as DMZ, that is demilitarized zone. Demilitarized zone is basically you want to have a differently aligned network itself, which will monitor or block the traffic. Then there are two types of firewalls. One is hardware firewall, one is software firewall. A hardware firewall is either dedicated standalone or device, or it comes as a part of router. Usually now that doesn't happen. It comes only as a standalone hardware. Usually hardware firewalls are used in all the organizations. The packet, we'll see this packet filtering technique and everything. Basically, it is the same thing that I explained. Just again, we'll see go through that. And it is used to filter out network traffic for large business network. Software firewall is a software program installed on a computer just like a normal software. Even over here, you can see, we'll see this. So this is what is your firewall. And you can over here, you can just, create your own rules and everything. So there is some, you can, if there is any particular application that you want to allow, so for that it is there. Now over here also, uh, now you can see over here, right, inbound and outbound rules. So you can also explore your own firewalls as well. So let's say I want to allow some of the uh, I want to create a rule which will either block or allow traffic. So here are any program that a particular app that you want to create a rule for, or a port that you want to allow. There are some predefined as well. See, these are predefined rules that are already present. Then there is custom rule as well. Let's come to port. You can specify over here. You can see, right, example. You can have TCP or UDP, and then accordingly you can mention the port. Let's say I have mentioned port 80, port 80. Also, you can just give a range as well, right? 80 to 8080. So any port that is coming to and from 8080, the rule will be applied. And then you have to decide if you want to allow the connection if it is secure. Now what does it mean is basically it has some other criteria. If it is authenticated and integrity protected, so there will be authentication that is done. See, by using IPsec. So IPsec tunnel will be there. Then there is encryption that is present. If it is encrypted, then only it should be there. Then if it should allow this can be an additional one. So here check mark is there. If you want to write block rules and everything. So this is how it is created, or you can just block the connection and it will get blocked. Okay, now I'm not creating anything, but I'm just telling you how it works. So yeah, basically this is how the software firewall works. Same, this normal firewall also works, but just that, we have this availability of the firewall to check. We have just went through it. Of course, you can go through this. There are some advantages, disadvantages. Uh, so for hardware, basically, if you are installing a hardware, there will be some hardware cost as well. So because of it, the cost increases and it is difficult to implement and configure. Then there are some firewall technologies. What it means is basically some kind of firewall types of firewalls. There is one firewall which is not mentioned over here. That is your firewalls that are currently being used, which is your next generation firewall. which contains all of the facilities which were previously absent. I'll tell you how what is exactly what I mean by it. So first is our packet filtering firewall. Packet filtering firewall is basically the same where what we saw, where any uh, packet or particular port traffic that you want to block, particular protocol traffic that you want to allow or block. So these are all the whatever it work happens, happens at the packet filtering firewall. So just remember the OSI layers, which firewall works at which OSI layer. So this works at the network layer, and each packet is compared to set of criteria before it is forwarded. So I told you, right? So if we block any connection to and from port 80, it will get checked against it, and then it will decide if you want to allow or block it. Rule includes source IP, destination IP, source and destination port number, and protocol used. So you can mention, I told you, right? So that any rule. So either you can apply any rule where any traffic that is coming from this network or any traffic that is coming from outside network, a specific port that you want to block, and then uh, the protocol that is used, that is TCP, UDP, and all of those. So yeah, this is how the packet filtering one works. Circuit level gateway is basically your proxy firewall. So proxy we already seen, right? Where it will hide your identity behind a servers or something like that, or a proxy server. So in the same way, firewall works in the same way where it will act as a proxy server. It will, whenever a traffic is being sent, it takes the IP of the circuit gateway, which means your firewall or any of the what we can say any gateway that is, let's say if I use proxy server or proxy firewall, and from inside a network I am communicating with someone in the outside world, that is internet. So in that case what happens is your uh, uh, your IP address will be hide behind those uh, firewall IP of proxy firewall. And someone, if tries to monitor your traffic or something like that, the system's IP or the server's IP won't be visible. It will show as the firewall gateway proxy's IP. So it masks your individual IP addresses, and they allow or prevent data stream. They do not filter individual packets. Then there is application firewall. These are that work on the application layer of the OSI model, and basically any of the services that are allowed or restricted to any of the application, for those this firewall is implemented. So if you want to, if any of the application wants to uh, allow or block certain network, or certain policies needs to be implemented, those are applied at the application level firewall. Stateful multi-layer inspection firewall, those are a combination of all the three firewalls that we saw: packet filtering, circuit level gateway, and application level gateway. Firewall, sorry. They filter packets at the network layer of the OSI model to determine when the sessions are legitimate or not, and evaluate contents of the packet of the application layer. Proxy we already saw. So an application proxy works as a proxy server and filters connection for specified services. It filters based on the service and protocols appropriate to that application. So for example, if an FTP proxy will allow only FTP traffic to pass through and all the other services will be blocked. So based on the type of protocol or services that you have implemented or you want to implement, based for that application proxy is present. Now all these facilities are also present in nowadays of the app, firewalls. Are you aware about the net concept? Have you gone through it? You must have had in the uh, networks lectures, right? Or you don't have went through. Hello, speaking
No,
anything.
sir, we don't.
Okay, netting concept hasn't happened. So I'll explain you in the simple terms. Okay, now let's say if an organizations have any organization has hundred of systems, which includes your servers, routers, switches, your personal laptops, and everything. And now it is obvious that each one will have a separate IP address. Correct. Now, whenever that IP address wants to, connect to the outside internet world, then they won't have that particular public IP address. Correct. They'll have this, what we can say, uh, private IP address. And if that particular what we can say, if there is some server, right, that wants to have connectivity to the outside world, so from that 100 there are 50 servers that that needs to be get connected to the outside world. In that case, assigning 50 public IPs is not a good option. Correct. Because whenever you purchase an IP, I mean, whenever you assign an IP, you have to purchase an IP because those are publicly available IPs. So whenever you see that, any IP that is like uh, public IP, let's say 115.113 that one dot 213 and dot 104. So this is a public IP, and that public IP is basically uh, available on the internet. But whenever you occupy it from the internet, you have to pay for it. So to avoid it, firewalls have provided a concept called netting, where it will provide you a netted. So let's say one of the server is provided some public IP, and that public IP is mapped to the private IP of that server. What I mean is, I'll show you with the dashboard over here. Now let's say this is a server. Okay, this is your firewall, and this is your internet. Now this server has some uh, private IP. Let's say 10.20.3.1. Okay, and it wants to connect to the internet. So what it does is basically uh, it has connected to the firewall, and then it has connected to the internet. Now, because internet wants the, because they cannot connect to the private IP because there are hundreds of private IPs that are there, and you don't have access to a private IP directly for the internet, obviously for the security purpose. So what happens is firewall will perform the netting, which means is they will provide the sorry, what they'll do is this, they will provide basically uh, map is 10.20.3.1. 20.3.1 to a public IP. Now I am giving a random public IP over here, 115.3.5.1. So whenever someone wants to send the traffic from the internet, it will enter the IP address as 115.30.5.1. Okay. And they will use this IP to communicate over here. Firewall will see this public IP and it will understand that actually it wants to send it to uh, basically this part. And then it will forward that same traffic to the server. So this, kind of saves your cost for the public IP. And obviously, even if you decide to purchase the IP addresses, all the public IP addresses, it will be very difficult to maintain. Those will exhaust. So for that reason, netting is done. I hope the concept is understood. Same here it is mentioned, it limits the number of public IP addresses an organization can use. But it can also act as a firewall filtering technique, which will allow certain connections which originate on the inside network and block the connections which originate on the outside network. So it can also work in that manner as well. Virtual private VPN you must have heard about. A it is a basically a private network constructed using public networks such as internet. So basically, itself private network is created which using the public internet, and all the communications happen in a secure and transmission. I mean, the secure transmission happens for this particular VPN part. It establishes virtual point-to-point connection through use of dedicated connections. Or also you can see that VPN are used for connecting WANs and they allow computers on a network to connect to computers on the other network. So basically, yeah, VPN is something where uh, it provides a gateway, which actually this is not a public network. It just, create kind of its own private network, which is similar to what it has with the public network. So it is a private network similar to using done through the connection of the WAN. Now you can see all these limitations where it does not protect from viruses and backdoors and everything, right? So I told you that there is one firewall, which everyone uses right now, which is your next generation firewall. These firewalls will not only have its packet filtering technique, but it will also have other modules like IPS and IDS. It will also have your antiviruses, and it also works as your I for creating the VPN part. It can also create or work as your net and for your netting part. It will also create your IPsec tunnels and everything. So now these limitations are being covered up using next generation firewall. All these, kind of what we can say limitations that it had, it has now covered up. Then comes our honeypot. So we in the social engineering module we saw honey trap where a person will pretend to be someone else and then it will try to lure you and then they'll extract information from you. Honeypot works in the similar way in a technical part. So it what it does is basically it is something as a vulnerable system. Okay. And uh, it what it does is it sets up to attract and trap people who attempt to penetrate an organization. So let's say if someone is uh, trying to breach into your network. Okay. It scans all the services, your IPs and everything. But it says one of the server, which is your honeypot, which so for him it is, it is an vulnerable open system. He is not aware that this is a honeypot. For him, he has found a server which is a vulnerable server. But actually, it is a honeypot where it will, perform all its hacking part and everything. It will try to attack and everything. But it is a dummy basically device, and the organization can learn from it. They can see what kind of activities are being done by the attacker, and it will, in fact, what we can say, it will monitor or record the attacker's activity itself. So let's say, I give just give the example. If he wants to attack, so you can see right over here. Basically, it understand that this is a vulnerable server. It will go and try to attack it. And whenever whatever the operations that are performed over here on the honeypot, the tool will capture everything, and then based on that, to protect the organization, it will take that certain measures. Now let's say uh, it goes to honeypot and tries to exploit any of the vulnerability, and you come across and see that, oh, that we are still open to that vulnerability as an organization, we haven't patched that, or there is some service that is being exploited by the attacker, and that attacker that exploit is not patched from our end yet. So this is how it is actually helpful to block the what we can say, attacker's future attack. And it is important to remember that this honeypot is never a part of your uh, network. So it will be placed separately. It will have a different route and everything, because otherwise what will happen is this is basically a vulnerable system. This is not a patch system, because we are luring the attacker. This is a patch system, and it has to be, sorry, it is not a patch system. It has to be a vulnerable system itself. So if you keep that connected to into your network, it will cause an issue. Like it will, provide, instead of, acting as a honeypot, it will basically provide as a gateway to your internet, sorry, your network. There are then four types of honeypot. So first is low interaction honeypot. These simulate only a limited number of service and application of a target or network. So there will be just a few number of applications or services that are monitored. Medium interaction honeypot simulate a real operating system, applications and services of a target network. So they act as a real operating system, and all the monitoring is done on that. Uh, High interaction is basically, so what we are trying talking about is the type of vulnerability that is present on the honeypot. So low will have low vulnerability, medium will have medium vulnerability, high will have high vulnerability, or they will open all their services and applications. And another is pure honeypot. They emulate the real life production network. So whatever, they'll act as what we can say. They will act like, legitimate organization which will have certain policies, and it will block certain traffic, but it will not block everything. So it appears to be very genuine to the attacker, because he won't come across, or he won't think that this is actually honeypot or something like that. And classification honeypot are done based on that deception technology, that is malware honeypot, database honeypot. So whatever type of honeypot that you want to monitor, based on that it is decided. So if you want to monitor emails, so for that email honeypot is there. If you want to monitor database, so for that I mean the database related exploits, so for that is there. Tools are there, we will see those tools later on. But over here you can see, right, log TCP any and the outbound traffic. So any traffic that is going to and from this particular gateway with this particular port, then it should be allowed. So such kind of or blocked. So such kind of rules it is created. By the way, don't install honeypot on your own system, because again, as I said, it can provide what we can say a gateway like something like that to your system itself. Then there are certain IDS invasion techniques that some of that we will see. So insertion attack and the evasion attack are similar. What happens over there is some particular pattern, right? So we saw it has some signatures that are present based on the patterns. This is basically modifying that pattern. Now here what will happen is basically an IDS. Uh, so it in this the attacker confuses IDS by forcing it to read invalid packets. So basically, in this, what happens is an IDS, so in the second point it is mentioned, an IDS blindly believes and accepts packet that are coming from an end system, rejects, and an attacker exploits this condition and insert data into IDS. So anything that is rejected, by the IDS, those same will be what we can say, those data streams, or those particular rejected ones are, uh, let's say, oh, how can I explain? So this is something where the attacker will try to provide extra traffic and or the extra packets into the packet, because of which the attacker thinks that this is a harmless traffic, and it will keep sending the what we can say, malformed packet, and the idea won't be able to detect is that malware, or some harmful traffic that is coming into the network. Evasion also does the same thing. So what we can say, so if any of the traffic that is rejected by the IDS by mistake, so those streams are then accepted in the next packet, and then the IDS is basically what we can say, evaded. DOS we yesterday saw itself, right? So if whenever you perform DOS, the pool will be filled up, and the IDS will be it will go into the what we can say, non-detection mode, because it basically uh, causes the displays to fail, and the tables will be filled, and it will become inactive. Obfuscating is basically using coding techniques. So some of the so let's say if it has encoded certain parts in Unicode, it will bypass the IDS, because IDS won't be able to what we can say, identify the Unicode. It won't be able to decode it, but those will be decoded at the web server, because it is understood by that. But IDS won't be able to you decode it. So that is why if any packet or any payload is unicoded with some patterns, then it can bypass IDS IPS. Again, now this is the technique which was earlier present. Now The technologies are improved for the IPS IDS, and they are able to monitor the unicoded or HTTP encrypted traffic as well. False positive generation. So if you send purposely, if you are sending malicious traffic, right? Basically, it will create lot of alarms, and lot of alarms are present, and then because of which, what will happen is, whenever the even if basically this will work only in the case of IPS, sorry, IDS, because IPS will directly block all the traffic. But in case of IDS, if it is just generating false positive, and the what will happen, it will generate lot of alarms. So whenever the admin is looking into those false positive alerts, it will somehow miss the uh, what we can say, the actual legitimate attack. So what may happen is, let's say if I send thousands of malicious traffic just to create noise, those are all false positive. Those are something where I don't want to attack, but I'm just creating noise. And if I'm sending it, after which, in that middle of that, I just send one of the real attack, then it may happen that this real attack will be missed by the admin team. Sessions splitting is where it will split the traffic. So basically, it will divide the traffic, or there will be a time delay between sending the traffic, and because of which the reassembly of at the IDs won't happen, and since because of that, the signatures won't get triggered. Unicode we already saw, that was the similar one to uh, this, and that coded and the Unicode is the same thing. Fragmentation, again, this packet will be fragmented, or divided into multiple small data streams, and because of which the reassembly of the packets won't happen, which will not trigger any alerts. Overlapping fragmentation is basically where that not only the packets are divided into multiple data streams, but it will also uh, send it on the high number, and because of which the IDS will basically not able to again match it with the signatures present. Time to leave, you must be aware, like whenever you do trace route, there is some trying period. So he's trying to reach the next stop, but sometimes what happens is, basically it is not able to reach that particular next hop. And the reason is not because it is not reachable, it is because that uh, there is some traffic congestion or something like that, or there is some packet queue is there, or something is there. And basically all these whenever it is trying, there is some time that is given, otherwise it will keep sending and queuing up the traffic. So once that threshold of time to leave is expired, that traffic is, or that packet is basically dropped. So that is where, if that packet that is being sent, it is set to maximum threshold value, then again the IDS won't be able to reassemble the packets, and because of which it will just bypass and get undetected. This is similar to RST ones, the uh, checksums and everything. So this is not something which usually has any meaning right now, because all these are easily detected now. Application layer attack. So any application where if you have like compromised, so even these are right now no of no use, because even the zip file and everything, and compromised file are also now, or even encrypted file are also somewhat detected at much greater percentage. So even those are not useful. Same. Evading firewalls. Some of them can be done, but let's say traffics like HTTP tunneling, SSH, DNS tunneling, even those are now, if yeah, if you're somewhat like what we can say, if you're not having secure network and you're allowing HTTP traffic to be going to and from, allowing that, then this tunneling will work. Otherwise this won't work as well. Port scanning, again, firewall identification is where, if you are seeing the port scanning is done, and let's say there are some unique responses for that, then it is identification of the firewall with along with the vendor. So for example, over here there is Checkpoint firewall. Checkpoint is basically a vendor, and it listens on this particular port, and the Microsoft proxy server listens on to this TCP 1080 and 1745. So if you want to identify which vendor's firewall is present, then you can just do the port scanning, and it will see what kind of ports are open over there. Firewalking is something that we already discussed right now regarding the TTL, time to live. Based on that, you can understand that this firewall is present, and you can then try to increase that TTL threshold to maximum, which will allow the traffic to go uh, uh, through the firewall. Banner grabbing, again, it mentions the services like SMTP and FTP and Telnet. Now no one allows FTP and Telnet protocols and services to be allowed publicly. So IP address spoofing, attacker may try to do this if it has actually masking its IP addresses. So let's say if there is a particular IP address that is being allowed over the public network, uh, for an particular IP address, and that if you are able to get that information, you may try to use your IP address as that particular IP address, which will allow that traffic to go to and from. So let's say uh, IP address for and protocol port 80 is allowed for a particular IP address, and you are able to understand that this IP address has an allow policy on the firewall. You can use your system as a, what we can say, as as in that, like spoof your IP address with that particular allowed IP, and then try to invade the firewall. Source routing allows the sender of a packet or partially to completely specify the route uh, the packet through the network. So basically routing is there, but even if the routing is there right now, it is not possible to basically event. Now what we are seeing is it will not go through the firewall, and it will go through some particular route. But usually now, no organizations allow such kind of traffic to go through, where it will allow to evade the firewall. All the traffic is basically what we can say, terminated at the firewall. And if you have any other such kind of scenarios, then there is some branch firewall that are installed. Branch firewall is basically, so also like this is not mentioned in this module, but there are two types of firewalls in another part case as well, which is your branch firewall and your perimeter firewall. Perimeter firewall is your main firewall which controls all the traffic, and branch firewall will have small capacity firewalls are there. Functionality remains the same, just those are small capacity firewalls. This is also now used, even if like using of IP address in the place of URL, but eventually now firewalls are that intelligent to decode them. So what we'll do is we will see some of the firewalls. We have a demo version of those firewalls. We'll try to see that. Let me stop us sharing for a minute. Let me reshare it. Just for one, I'll open the app of it as well.
Good afternoon, sir. Varad here. Right. Um, Hello.
Hello.
Sir, Varad here. I want to give one message to all student that LMS login credential has been sent to every student. Please, everyone try to log in. If anyone facing any issue, so let me know. Okay.
I'm resharing my screen. Yeah. Varad, you're done? Like,
Yes, sir. Yes, yes, sir. Okay. Thank you, sir.
we have taken demo instances of two basically firewalls. One is your FortiGate firewall. So this is this and Sophos firewall. FortiGate is widely used. Okay. So as you can see, this is how the look and feel is there of the firewall. It shows how many how much CPU is consumed and what are licenses that are present. I told you, right? These are the antivirus and everything. IPS is also there. Web filter is also there. Web filter means which URL should be allowed and which URL should not be allowed, basically. All this is now available in your firewall itself. This is called as next generation firewall. Okay. This NGFW means next generation firewall. And then from here you can see what are the now this is since a demo version we are not allowed to have policies on this FortiGate, but I'll show that on the Sophos how the policies are present and how we can create those policies. But yeah, this is how the firewall basically looks like. Let's see it loads or not. This won't load. Let's see, it's trying to search for policy. Okay. There are no policies that are present right now. But what we'll do is we'll see what are the top threats that are present over here. It's not moving. Let it be. Uh, Coming to security profiles, it won't have any. So you can see that what are the different types of antivirus policies that are present. Here you can see what are blocked, what are present. Right, so it has so this is something which is it is in the monitoring mode. So any traffic that is coming from HTTP, SMTP, POP3, IMAP, these are all in the inspected protocols. So any traffic that is coming from here will be inspected. Web filter will monitor all the URLs that are going to and from. You can add. So over here, as I told you, right? So we have this demo version, so it is not allowed. But you can add from here if you want to add any particular URL. So This you can have it on your blocking mode or anything. So if you block this, any URL that comes under this particular category, it will directly block it. If you have any drop of views you want to block. So instead, so whatever this will all monitor. So by monitor, it means is any traffic that is related to this one, it will monitor. But if you decide to block, it will directly block. Then it is your IPS signatures. Yeah. Ideally, IPS tool differently is used, but this next generation firewalls basically have their own signatures as well. And any traffic that matches this particular signature will get blocked. You can see all the summary and the threat ID and everything. If you check the threat ID, you can go on to the threat ID as well. And yeah, you can see the CV number as well, right? So they have all these details. It's MITRE framework as well. So everything is there in this part. Then from here, usually, there is section where you can monitor the traffic that is going to and from. But there is a concept of syslog, which we will see, which we will have a lot of lectures on. So, to monitor and create alarms, SIEM server or SIEM tool is used. And for that, your traffic should be forwarded or to the syslog server. What it is and how it works, everything we can see in the those sessions. And this is Sophos firewall. Again, you can see, right? Intrusion prevention is there. Any flood traffic, if you see uh, those type of signatures are already present. Email is there. So there are different policies. So um, you can see here if you want to create any rule or anything. And I was talking about the policies, right? So we'll check that policy. So over here, if you want to add new firewall rule, you can mention the firewall. Let's say application HTTP. This is for HTTPS for web application. You can enter the description. Role position. Now, what does the role position mean? So basically, there are different positions of the rule. So now, let's say you have 50 rules, okay, 50 policies that you have created, and whatever, whichever the policy is at the top, that will get applied first, then the next one, then the next one. So if you have any related policy to same server or same protocol, it will first get applied. So you can also decide the position for that group. That is fine. Source zone. So we saw that, right? DMZ, LAN, VPN, WAN. Then you can mention the source network devices if you have any network devices and everything. Zones and services. So services you can mention, let's say if you want to HTTPS. Obviously this won't allow, I guess, yeah, because of demo version. But what we are trying to see is there how it works basically. You can mention the where is it source. Over here you can mention the source, you can mention the destination, and you can then decide if you want to allow or block the traffic. So if you decide to drop, reject, so that you can also do it. Understand like how this all firewall and everything basically works, and how the uh, what we can say, the policies and everything are created. Net rules I told you, right? So Natting is also done. Let's see any one of the rule. So this is dummy one, so don't think we'll get anything. Mm, no. Just try new rule. Let's see if we can have anything. Okay. No, not allowed to do that. But it's fine because this is a demo version, and but we can't have firewall, right? So we have got the demo version for that, and from that demo version, we are able to see how we can create the rules. Log viewer is basically where you can see the traffic that is going to and from. So so you can see the source IP, destination IP. If the log types of so it is denied and the action is dropped or denied, or protocol which port it is going to. This is how the log files look like. Okay. And another tool that someone yesterday asked the question that how to send particular packet traffic, right? So someone had asked that question yesterday. So this is one of the tool which basically is used for packet building. So over here, what you can do is basically give the source IP, which is your. So if you want to spoof, you can spoof that IP. I have just copied it. Otherwise, if you want, you can spoof that IP, mention over here as it, give whatever the destination you have. Then you can select the packet type. I have selected TCP, send now, no scripting. And over here, you can select whatever files that you want, and then you can send the TCP packet. Obviously, there is no destination as such, so that is why it will give an error because there is no destination like this since we are in a single network. But this is how you can basically what I wanted to show is you can send a customized packet. Also, there are some scripts that are by default present by this tool given, but basically, you can create your own script as well using Python, using C hash, which will set particular flags and send the packet. You here we discuss this time to live as well, right? So you can mention the time to live as well. So 5542, anything that you wanted to give. So basically, you can just play with this tool and decide what you want to give it. And this has a packet capturing tool as well. Otherwise, you can also have this what we can say uh, Wireshark that we saw it. So even those you can see on capture. Anyway, okay. So any questions? Fine, then I guess we can conclude. Thanks for joining.